Welcome, ladies and gentlemen, to Integrated Math 2. In today's episode, we will be discussing Chapter 5.2.4, which is an introduction to the quadratic formula. We will first start off with 5-95, and we will say, consider the equation x squared minus 3x minus 7 is equal to 0. Use the zero product property to solve the equation. What happened? What does that tell you about the solutions to the equation? Well, first off, x squared minus 3x minus 7 is equal to 0. Remember, guys, the zero product property says that we would factor and set something equal to 0, and then we would set the individual parts equal to 0. But as we're quickly starting to notice, this quadratic is not factorable. So it's not factorable. So what does that tell us about the solutions to the equation? Well, as we've been learning as we progress through completing the square, when we have to do completing the square on a quadratic equation, it means that the x values that we're looking for are not rational numbers. So let's get that in our notes here. The x values or solutions for x, the solutions for x are not rational numbers. And that seems to be the thing that we go to when we don't have that situation where we can factor something cleanly. We end up using completing the square on it. And that's actually part B. They tell us to solve the equation by using completing the square. Now, whenever we have an odd value here for this middle term, completing the square usually isn't the preferred method in my book. It's actually going to be the method that we're learning today. But you know, for now, all we have at our disposal is completing the square. So I'll go ahead and just do x squared minus 3x. I'm going to leave myself space with a 7, and I'm going to add the box on both sides. And again, I drew the box like that because we're going to end up having a fraction in there. So that's going to say negative 3 halves in there. And so from here, by putting it as a fraction right here, it makes our life a lot easier, because now all I have to do is take 1x, 1 negative 3 halves, and square the entire thing. This guy is going to be a little bit harder here. It's going to be 7 plus 9 over 4. I'll go and just do him on the side here. I'm going to need a common denominator. It's going to be 28 over 4 plus 9 over 4. So I'm looking at 37 over 4. When I take the square root on either side, I'm going to get x minus 3 halves is equal to plus or minus the square root of 37 over 2. A couple things to note. Don't forget the plus minus. We just took the square root of an x in the middle of an equation. We talked about that with the looking inside method a couple of lessons ago. And I also took the square roots of the individual pieces, the square root of the 37 individually from the square root of the 4. And I did that because the square root of 4 happens to be 2, and we can find out what that is. So with this in mind, I've got adding 3 over 2 to either side. So I've got x equals 3 over 2 plus or minus the square root of 37 over 2. Now, because I have the same denominator, I'm going to do two things at the same time. I'm going to split my answers apart, and I'm going to combine my numerators together over a singular denominator. So what I really have is 3 plus root 37 all over 2, and 3 minus root 37 all over 2. And those are the two answers right there for our values of x. And again, because we can't find the square root of 37, at least not, without a calculator or some kind of guessing mechanism, that's pretty much it. Our number is going to be absolutely irrational. So there's the answer to B. And again, we just couldn't factor it because our answer was not going to be rational. And now it says graph on the graphing calculator, and then we have to estimate the solutions to the original equation, and then does that confirm our answer? I believe it does. Give me a second. Let me go ahead and pull up the graph. And here is the graph of x squared minus 3x minus 7. And let's go and find out those x-intercepts. Remember, every equation we solve has a graphical interpretation. So what we were doing in the context of a graph was finding the x-intercepts. Now what you'll find is that these two numbers here are those irrational numbers that we found on the previous board. So this would be the version of 3 minus rad 37 over 2 would be on the left side. And then 3 plus rad 37 over 2 would be this 4.541 number. And I would encourage you to grab a calculator, check it out for yourself, but you will find those to be the answers of the x-intercepts and x values that we found in the previous problem here. So yes, we can confirm that. Cool. All right, let me go ahead and pause, and I will be back with the next problem. And in 5-96, they roll out this formula known as the quadratic formula, which is another method used to solve a quadratic equation. And it comes in the form of this. And it's a little hard to see on here, so I'll go and write it out for a little bit larger for everybody. It's x equals negative b plus or minus the square root of b squared minus 4 times a times c, that's an a, all divided by 2a. It's a long, threatening formula that people tend to get a little intimidated by when they first see it. And actually, in a separate video, I'll probably show you where that formula comes from. It's not just some formula out of nowhere that people kind of came up with. In fact, I am confident that all of you know how this formula is gotten. But we will do that in a separate video just so that this one doesn't take up too much time here. But basically, this is the third and final method that we have for solving a quadratic function here, or a quadratic equation. At first, we had zero product property, which involved factoring and solving for the x values when set individually to 0. That was great when the quadratic was factorable. Completing the square was great also. It helped us deal with factorable quadratics, but it also helped us deal with non-factorable quadratics. And then the last one is the quadratic formula. And actually, in another separate video, I'll probably do which method is advisable for each situation, just because you want to be able to have the right tool at the right time for each inevitability. So in part A, it says if x squared minus 3x minus 7 equals 0, then what are a, b, and c? Well, this should be hopefully obvious, with a being 1 because that's the coefficient in front of the x squared. B would be negative 3 because that's the coefficient in front of the x, and c would be negative 7. Now, if that wasn't obvious to you, that's okay. Let me go and take you on a trip down memory lane here with the notion that a quadratic is written in the form ax squared plus bx plus c. And from there, we can just kind of make those associations, with a, again, being 1, b being negative 3, c being negative 7. And now it says in part B that the quadratic formula calculates two possible answers using the plus minus symbol. And so remember, just like in completing the square, the plus minus refers to the version of the quadratic formula that is the negative b plus version, right? B squared minus 4ac over 2a. And I'm just rewriting them that way you guys can see it better. And then there's the minus version, which is x equals negative b minus the square root of b squared minus 4ac all divided by 2a. And so there are always two answers here. Normally two answers, and I think you guys know when we only have one. But it says carefully substitute a, b, and c for the equation and find out the value. Do we match from 5-95? Let's find out. So in this case, we know that a is 1, b is negative 3, and c is negative 7. So again, I'll plug those values into this mysterious quadratic formula here. I'm going to get negative blank plus or minus the square root of a blank squared minus 4 times 2 blanks, all divided by 2 times a blank. Now, this is my general setup for the quadratic formula every single time we deal with it. So I will go ahead and just fill in those blanks. So it's negative b, so that's going to be negative 3. And careful, those two negatives will cancel each other out. The b squared will be negative 3 squared. 4ac, that'll be 1 times negative 7, all over 2a. So now let's go ahead and simplify now that we've plugged stuff in. The negative 3 will become 3 plus or minus the square root of 9 plus 28, all over 2. And 9 plus 28 is 37 over 2. Now, I feel like this answer is familiar, this whole notion of 3 plus rad 37 over 2, 3 minus rad 37 over 2, and I believe that was the answer to our first equation here. So again, the quadratic formula, different means to the same end, and it's actually not much different than some of the other methodologies you've learned in the past. So like I said, in a separate video, I'll show you where the quadratic formula comes from. Give me a second, I'll be right back with some 5-97, which is a little bit of drilling. And we are back for 5-97 using the quadratic formula to solve for x if possible, and we're going to check our solutions here. So in part A, we're going to go and just label the parts here. So A equals 3, B equals 7, and C equals 2. And on the side here, I'm just going to write the quadratic formula again, just so that we know what it is. Negative B plus or minus the square root of B squared minus 4AC, all divided by 2A. So now we're going to just plug in the pieces here, just like I did before. It's going to be X equals, and you're going to hear me say this a lot, negative thing plus or minus the square root of a thing squared minus 4 times 2 things, all over 2 times a thing. And now we just have to figure out what things go in each bracket here. So that's going to be a 7. Let's see, 7 squared minus 4AC all over 2A. So negative 7 plus or minus the square root of 49 minus, what is this, 24? All divided by 6. So with negative 7 plus or minus the square root of 49 minus 24, I believe is 25. All over 6. Now, the square root of 25 is actually a clean number, so why don't we go and find out what that is? That's 5. So what I have now is I have negative 7 plus or minus 5 all divided by 6. Now, I'm going to go and break those apart and go negative 7 plus 5 over 6 and negative 7 minus 5 over 6. So that's going to be negative 2 over 6, which is negative 1/3. And this is going to be negative 12 over 6, which is negative 2. Now, what do these answers mean? Because I got rational numbers and not irrational numbers as my answer, what that means is that this 3x squared plus 7x plus 2 was actually factorable the entire time. So I can say 3x squared plus 7x plus 2 was factorable, right? We could have busted them out as 3x and x, put a 2 here and a 1 here, given them a double plus, checked it, 6x, 1x gets me 7x. And what do you know? X equals negative 2. If I set this guy equal to 0, I get x equals negative 2. If I set 3x plus 1 equals 0, I'm going to subtract 1, then divide by 3. X would equal negative 1/3. Now, oftentimes I will not use the quadratic formula unless I have to, but this problem is just here to show you that you can use the quadratic formula even if the numbers produce as rational, and there really isn't a huge problem with it, except it's just really not efficient to do that. And so with B, we have 2x squared minus 9x minus 35 equals 0. So again, just plug the stuff in. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Again, the best way you can get good at this is just to keep on practicing. So let's go ahead and plug in the numbers here. Let's go and identify them first, actually. A equals 2, B equals negative 9, C equals negative 35. So from here, negative 9 squared, 4AC, so negative 35, all over 2A, which is 2 times 2. So that's going to be 9 plus or minus the square root of 81. Let's see, negative times negative is positive. So what have we got here? This is 70, so 280 all over 4. And so let's go ahead and add these guys up here. So 81 plus 280 is going to be 361. So 9 plus or minus root 361 over 4. And 361 actually does have a perfect square. When you take the square root of it, it ends up being 19. So you get 9 plus or minus 19 over 4. So again, break them apart. 9 plus 19 over 4. 9 minus 19 over 4. So again, this is factorable because we were able to take the square root of the number inside and get something clean. So that's 28 over 4, which is 7. And this is negative 10 over 4, which is negative 5 halves. Cool. All right, let's keep on going with these here. So let's go with that 8x squared plus 10x plus 3, which is C. 8x squared plus 10x plus 3 equals 0. So again, let's go and just do the quadratic formula on this thing here. So I'm going to set it up with x equals negative blank plus or minus the square root of a blank squared minus 4 times 2 blanks all over 2 times a blank. So now that's going to be, well, let's identify the pieces there. A equals 8, B equals 10, and C equals 3. So 10, 10, and I hope you're getting comfortable with me moving this quickly. But here we are. So this is going to be negative 10 plus or minus the square root of 100 minus looks like 32 times 3, so that's going to be 96. And so from here, all over 16. So check it out. Another rational number that we're going to be getting inside. So negative 10 plus or minus the square root of 4 over 16. So that becomes 2. So what we have is negative 10 plus 2 over 16, negative 10 minus 2 over 16. So what we get is we get negative 12 over 16, which is, they both divide into 4, so negative 3/4. And then negative 12, oh, sorry, I think I made a mistake there. I think the top one is negative 8 over 16. Negative 8 over 16, which is negative 1/2. And this is negative 12 over 16, which is going to be, again, they both divide into 4, so negative 3/4. Again, when you get these rational numbers, it just means that what you're dealing with is factorable here. So let's go and take a look at the last one. I believe it's 5x, negative 5x and positive 9. So in the last one here, x squared minus 5x plus 9 equals 0. Now, my first suspicion here is that this is not going to be factorable because I can't think of any two numbers that multiply to 9 and add to negative 5 at the same time. So I think the quadratic formula is very much appropriate for this problem and not as useful, not as helpful in the last problems. We could have just factored the rest of the 3, but that's okay. The purpose of these problems is to show you that the quadratic formula can be used to solve for even factorable quadratics. And so x equals negative thing plus or minus the square root of a thing squared minus 4 times 2 things all over 2 times a thing. And so from here, negative 5, 1, 9. I see what's going to happen here. So 1. And so this is going to be 5 plus or minus the square root of 25 minus 36 all over 2. So 25 minus 36 is going to be negative 11 over 2, which unfortunately cannot be solved, so no solution. Again, that's because we can't take the square root of a negative number. In the context of a graph, I'm hoping you guys understand because, every equation has that graphical context to it. This graph is not going to have any x-intercepts. And what that means is that it's probably somewhere up here or up here somewhere. But you can feel free to put that on Desmos if you want to see exactly where that parabola is. I think that will pretty much wrap it up for this episode. This is just an intro into the quadratic formula. For now, you should just kind of focus on getting that formula down. That way you guys have it at your disposal. But as always, please leave questions or comments in the comments area, and I will see you all in the next episode.